Introduction to Geometry of Chemical Compounds. When considering the geometry of chemical compounds, you must take into consideration the lone pairs of electrons and atoms in a bond. You must always acknowledge that the lone pairs of electrons and the atoms in a bond occupy space, which determines the overall geometry of a chemical molecule. Bond geometries occur in order to minimize the lone pair of electron repulsion and maximize the separation between these electrons. In this video, we will take a look at three different kinds of geometries. The first geometry that we will look at is linear geometry. As shown in the picture, A indicates a chemical element and B indicates either a lone pair or another kind of chemical element. For example, in beryllium hydride, the beryllium and the hydrogen atoms both separate themselves such that they are 180 degrees apart, forming a linear molecule. Beryllium has two bonds and zero lone pairs of electrons, and thus 180 degrees would result in minimum repulsion and maximum separation between the two hydrogen atoms. The next geometry that we will look at is trigonal planar. Trigonal planar is common in molecules that have three bonds. Again, A indicates a chemical element and B could indicate either a chemical element or a lone pair of electrons. An example is boron hydride. Boron can form three bonds, and in this case, it forms three bonds with three hydrogen atoms. There are no lone pairs of electrons in this specific molecule, and therefore, in order to maximize the separation and minimize repulsion between hydrogen atoms, they each form a bond of 120 degrees bond angle, thereby separating the hydrogen atoms from each other. The third geometry that we will look at is tetrahedral. Tetrahedral is common with four bonds in a molecule. In the same situation previously, A is a chemical element while B is a lone pair or a chemical element. In our example, we will look at the ammonium ion. In the ammonium ion, the nitrogen atom has no lone pairs of electrons but forms four bonds with the hydrogen atom. The hydrogens are separated by a bond angle of 109.5 degrees, and this minimizes the repulsion between the hydrogen atoms. Note that the nitrogen does have a charge on it, but that charge does not affect the geometry of the molecule